Here comes the last question of this exercise, that is question number 14. In this question, we have to graph the absolute function. But before plotting the graph of an absolute function, let's discuss what an absolute value is. Absolute value means how far a number is from 0. So distance can never be taken negative. So we will always be considering positive values because absolute value tells you about how far a point is from 0. So the absolute value of -9 is 9. The absolute value of 3 is 3. Or we can say the absolute value of -6 is 6. It means that we will always be considering the positive values. So in practice, absolute value means to remove any negative sign in front of a number and to think of all numbers as positive or 0. There are different ways to solve absolute value function. I'm using the most simplest one. I'll be writing this function as a form of a compound function that will be based upon two functions. Because whenever you are taking off the modulus sign, two possibilities will take place. One with the positive sign and other with the negative sign under some given condition. So when you are shifting this 4 on the other hand side, the condition becomes x greater than or equal to 4 and x less than 4. I have also written the values of x in tabular form. I have represented its elements or its domain in tabular form as well so that you can easily choose your input. So I'll be choosing few values from this interval and few values from this interval. To construct my table, the corresponding values for given function will be like this. When you are taking your input as 0, since it is satisfying this interval, so you will be choosing -x plus 4 functional value. Your output will be 4. And when you are choosing any value from this interval, you will be choosing x minus 4 as your functional value. So after inserting the input, you will be getting your output. Now let's plot the absolute value function. For the input 0, the output was 4. Means when the value of x was 0, the functional value, the output was 4. So here is the point. So let me take another point. When x was 1, value of y was 3. When x was 1, value of y was 3. When x was 2, value of y was 2. So when x is 2, the value of y is 2. Likewise, you can construct this modulus function. Now let's solve the second part of the same question. Now you have to keep one thing in mind, that taking the absolute value of a negative number makes it positive. For this reason, graph of absolute value functions tend not to look quite like the graph of the linear function that you have already studied. However, because of how absolute values behave, it is important to include negative inputs in your table chart when graphing absolute value functions, right? If you do not pick x values that will put negative inside the absolute value, you will usually mislead yourself as to what the graph looks like. So inside the modulus sign is the linear function. So if you are only plotting this linear function, it will be giving you a straight line. But that straight line does not represent your absolute value function. So for that, you have to omit the negative output, because output is always positive in modulus functions, right? So let's solve this question using the same steps. Here is the function. When you are taking off the modulus sign, two possibilities will take place. And the condition defined is -4 minus x greater than or equal to 0, -4 minus x less than 0. So let me write the values of x in tabular form. So the values of x less than or equal to -4 are -4, -5, -6 till so on. And the values of x greater than -4 are -3, -2, -1, 0 till so on. So we'll be choosing few points from this interval and few points from this interval. Let me take my input as -8. So -8 is the part of this interval which is less than or equal to 4. So I'll be choosing this functional value, that is -4 minus x, to get my output. So likewise, you can take few points from this interval and few points from this interval. In the next step, you will be plotting these points. Let me check few points to make you understand. If you are taking, let's check the random values. If I'm taking -2, my input is -2. Check where is x -2. X -2 is here. What is the functional value? Functional value means the output is 2. So here is the point. Now let's check -4. When x was -4, -4 is here, and the value for the function, the output is 0. So y is 0 over here. When x is -4, y is 0. So this is how you plot the absolute function. Third example. You can easily do it on your own. Write the given function in terms of two function. It is likewise, it is similar to the compound function. You have written your modulus function in terms of two function, one with the positive sign and other with the negative sign, under given condition. Then write the values of x in tabular form so that you can easily choose the values of x from one interval and other. Then insert these values in the function according to the condition, and then plot the points. Finally, join those points to get the graph of an absolute value function. The last part of question number 14, that is y equals to f of x, which is equal to minus mod of x. I want you to solve this part on your own so that you can have an idea whether you are clear with the concept or not. After solving it, you can compare your answer with the solution I'm providing you, just to check that your concept is clear or not, right?